Hello everyone. So this is the part 3 of CSIR net PYQs of solid state chemistry, and this is the last part. Now starting with the question 1, both they have given both NaCl and KCl crystallized with FCC structure. However, the X-ray powder diffraction pattern of NaCl corresponding to the FCC structure, whereas that of KCl corresponding to simple cubic. This is because, see, for KCl na, you know that K positive and Cl negative, these both are isoelectronic. Isoelectronic means they are having same number of electrons, right? So because they are having same number of electrons, some peaks are missing, so the reason would be this. So we get the X-ray diffraction pattern corresponding to the simple cubic. Okay, you know, in X-ray diffraction, basically it depends upon the number of atoms as well as the size of the atoms. If your atom is small and lightweight, it will scatter it less, while if the atom is big, it will scatter it more. So the correct answer is A. X-ray diffraction does not give any structural information for. It's a very simple question. X-ray diffraction studies are basically for the crystalline solids, right? So these three are crystalline, this, while this is amorphous. So the correct answer will be 4. They have told does not give structural information, so 4th will be the correct answer. Okay, third question. For a simple cubic crystal, X-ray diffraction shows intense reflection for the angles which are assigned to 101, 111 planes. The ratio of sin theta 1 to sin theta 2 is, okay, we know that according to the Bragg's law, 2d sin theta is equal to n lambda. So if we talk about theta 1 and theta 2, the equation will become 2d1 sin theta 1 and lambda, because the X-ray we are using the same, so lambda value will be same, 2d2 sin theta 2 and lambda. Okay, when we take the ratio of both the equations, you will see these two will get cancel out, 2 with 2, so the final equation you will get sin theta 1 upon sin theta 2 is equal to d1 d2, that is d2 upon d1. Okay, now we know that d1 is a x square plus k square plus l square, right? Now for 101 plane, it will be a 1 square plus 0 square plus 1 square. This is a by under root 2, while d2 it will be a by under root 3, right? So evaluate this sin theta 1 upon sin theta 2, d2 a by root 3, d1 is a by under root 2. So this will be the ratio. So it's 1.414, 1.732. So when we take the ratio, it will come 0.82. So the correct answer will be 3. Okay. Now the next question is, silver crystallizes in the FCC structure. The second order diffraction angle of a X-ray beam lambda 1 Armstrong of plane 111 in the range theta is given 30 degree. Therefore the unit cell length, they are asking for A. Same formula will use 2d sin theta and lambda. From here we will evaluate d, 2d sin 30, n is 2, lambda 1, sin 30 is 1 by 2, so 2d 1 by 2, 2 into 1, so d you will get 2 Armstrong, right? We know that d is a h square k square l square Okay, so 2 equal to a, this 111 plane root 3, so 2 into 1.732 Armstrong, a's value, this will 3.464, so 4 will be the right answer, right? Similarly, fifth question, sine theta square value obtained from X-ray power diffraction patterns are, see, sine square theta value they given 2x, 4x, 6x, 8x, right? Where x they given 0.06. The wavelength of X-ray used to obtain this pattern, lambda value they given 1.54 Armstrong. The unit cell and the unit cell length are. Now this question is very easy. For this you have to remember one thing. For SCC, this you have to remember, okay? For SCC, the sine square theta ratio should be 1, 2, 3. That is any number, okay? For BCC, this ratio comes like 2, 4, 6, 8 sort of, okay? Even. And for FCC, the sine square theta ratio is 3, 4, 8 and 11. That is this is not any pattern, this you have to remember, 3, 4, 8, 11. Now when you look upon this question, in this the ratio if we take, it comes like 2, 4, 6, 8. So this will be basically BCC, for the BCC structure, right? Now they also asked about the unit cell length. We know that 2d sine theta is equal to n lambda. If you take n is equal to 1 for the first, okay, then sine square theta will be equal to lambda square on 4d square. Putting the value of d, you will get a square h square plus k square plus l square, okay? Now see, for first it is 2x, right? I can write this equation like this. If I take this value as x, h square plus k square plus l square. So what is x? It is lambda square upon 4a square. Now putting the value x they given 0.06, lambda square 1 this square, okay, 4a square. Now from here when you will evaluate a, it will come 3.14 Armstrong. So the correct answer will be 1, okay? This question you have to remember this. Now moving on to the next question. Polonium is only metal known to exist in a simple cubic lattice form. The density of polonium at 0 degrees measured with this density, it is 10 gram per centimeter cube. The atomic radius would be, then assuming the mass they have given, this is, they have given this ratio, okay, mass they have given this per atom mass, okay? So we know that density is Zm a volume, a is cube, okay? Now we evaluate d10, z is simple cubic, so 1 mass, this ratio is given 2.7 in 10 raised power minus 22 gram over a cube, right? A cube will be 27 into 10 raised power minus 23. Then we'll take this down. So a will come when we'll do 1/3 on both the side, okay? So it will come now you can evaluate it by on. It will come around 3 into 10 raised power minus 3 centimeter, okay? Now they have asked one second. So a will come when we will find this one. So A will come 27 into 10 to the power minus 4, this 1 by 3. Okay, this is 3, 1 by 3 is minus 8, so 8 this much, okay, centimeter. Now they have asked about the atomic radius. We know that 2r is equal to a for SCC, radius will be a by 2, so 3 into 10 to the power minus 8 by 2, 1.5 into 10 to the power minus 8. Okay, so this will be 1.5 Armstrong. Okay, in this question you have to note that here r came in centimeter. Okay, so this is will be equal to 10 meter, which is 1.5 Armstrong. So the correct answer will be 3. Now moving on to the question number 7. The separation of 1 to 3 planes of an orthorhombic unit cell is 3.12 nanometer. The separation of this and this will be, here you have to use a simple formula, D N H N K N L will be equal to D H K L divided by N. Okay, so here D H K L, that is 1 to 3 is 3.12 nanometer. For finding 2, 4, 6 you have to divide it by, see this is a multiple of 2 है ना, 2, which will be 1.56 meter. For finding 3, 6, 9 you have to, this is when we multiply 1, 2, 3 by 3, so this will come here and will be 3, so we'll divide it by 3, it will be 1.04 nanometer. Okay, so the correct answer will be 1. Now moving on to the next question. Here given with 002 plane of FCC diffracts X-rays which is of wavelength 0.1454 nanometer at an angle of 90 degree. The density of the crystal is this much per meter cube. The atomic weight of the elementary state. Okay, they're asking for atomic weight. Okay, so we know that density is Zm Na cube. Okay, now in this question for FCC, Z is 4, you have to find M. Okay, N is Avogadro number, D is density given. Now the main question is you have to find A. Okay, we know that they have given us theta. Okay, so we'll use 2D sine theta and lambda. Okay, for D this one formula we'll use L square sine 91, lambda they have given 0.154, so 2 into A, plane is 002, so this will come 004 1 this much, so you'll get from here, this is under root 4 which is 2, so this will cancel. Okay, so A you'll get 0.154 okay nanometer. Then you have to put this value over here. Density is 4 into 10 raised to power 4, Z is 4, this we have to evaluate. N is Avogadro's number. Okay, A this much nanometer, you have to convert it into meter because density is kilogram per meter cube. Okay, into 3 whole, right? Now when you will evaluate this one, okay, so the mass you will get 22, this is 22, right? Ninth question, a metal crystallized with cubic close packed structure CCP, the sine square theta value of the Myler, please, this and this and this, your unit cell length is how much? Okay, we know that for the value for this plane sine square theta is this one, for 111 its value is this one, right? Now they are asking to find the unit cell length, that is A. Okay, simple. See, we know that 2d sine theta is equal to n lambda. Okay, n will take 1. So when we'll do its square, it will be 4d square sine square theta lambda square, right? So sine square theta will be lambda square upon 4d square. Now if we put the value of d, we'll get lambda square upon 4a square h square plus k square plus l square, right? Now evaluating everything, this equation will use lambda square upon 4 a square, it will be 4 plus 0 plus 0. So we will take a square here, lambda square, 4 cancel, 0.18. So a will be lambda root 0.18, which will be approximately equal to lambda 0.4. Here you have to use the approximate values. Okay, now the 10th question. X-ray of wavelength 173 picometer are reflected by 111 plane of a cubic primitive crystal of theta 30 degree. The unit length in picometer is close to. They are asking for A. This is easy question. Directly you have to employ this Bragg's law. And 173. Okay, so 2 dA under root 3 sine theta 1 by 2 173. The 2 cancel, so A is 173 root 3. So this will be the value. Okay, while evaluating this, you will get the value 299.63, which will be approximately equal to 300, right? Moving to the question number 11th. In a cubic crystal, what will be the interplanar distance? You have to calculate d of this plane showing first order reflection at 60 degree. We are using lambda 1.54 Armstrong. Okay, so simple, 2d sine 60 is under root 3 by 2 and lambda. What will be the interplanar distance? Okay, d will be 1.154. No, it's 1.54 divided by root 3, right? On dividing this, you will get approximately this one. Okay, because obviously the denominator is greater than numerator, so the answer will be less than 1. So the correct answer will be 1. Now question number 12. The 110 reflection of X-ray diffraction pattern of a monatomic matter crystallized in the BCC structure. Distance is 3 Armstrong. The nearest neighbor distance in the crystal. They are asking the nearest neighbor distance. Okay, in BCC we know that 4r is equal to under root 3a, and nearest neighbor, let's say it is d, it is always 2r in BCC. So nearest neighbor, that is 2r, will be under root 3 by 2a. Okay, now they have given us d and this. Okay, we'll employ interplanar distance formula, h square k square l square. D is 3 a root 2, so 3 root 2 will be a. Okay, now evaluating this value in here, you will get d is equal to under root 3 by 2, a is 3 root 2. Okay, So upon solving this, you will get 3.67 mg. 13th question. Iron belongs to BCC lattice. Okay. The Miller index of the second allowed reflection of the powder diffraction pattern would be, in BCC the rule is H plus K plus L, all should be even, right? See, this is odd, their sum is odd. Okay, this is even, this is odd, so the correct answer will be 3. This is a very one-liner question. So in this you have to remember just a simple formula and the concept. Okay, the lattice structure of alpha iron who is having BCC are shown with some lattice planes. You have to tell which will not show X-ray reflection. Okay, in BCC same you have to follow. You have to see HKL plane and their sum should be even, right? Now if we are starting with 1, A option, right? 1, all sum is odd, so this is not. Here even, this is yes. Here odd, not. Here is even, yes. But they have asked about which will not show. Obviously A and C will not show, so the correct answer will be 2. Then the separation between the first two reflection plane of a face centered cubic crystal is, okay. Now in FCC the rule is HKL, it should be all even or all odd. Okay, this is the rule. Now they are asking for the first two planes. Okay, for the first two planes, like 1 1 1 will be the first plane, all odd. Okay, then second plane will be 2 0 0, all even. Now if we say DHKL, here distance, it will be A root under root 3. Here DHKL, it will be A under root 4, which will be A root. Okay, now you have to find the difference. Okay, D 1 1 1 minus D 2 0, so it will be A under root 3 minus A root 2, right? Now you have to solve like this: 732 minus A 2. Okay, when you will see this now, 1 by 1.732, it will come 0.57A. This is 0.5A, so the difference will be 0.07, so the correct answer will be A. Okay, now next question, the XRD pattern of crystalline material measuring using the copper radiation of lambda value. This one is as follows: considering a cubic edge length, you have to consider 4 Armstrong. The Miller indexes and the Bravis lattice of this material is. In this you have to calculate HKL. Okay, this is basically a numerical type question, lengthy. Like they have given 2D values. Okay, let's say we know that Bragg's law is 2D sine theta is equal to n lambda, right? So here 2D is given for first 38.43. Theta will be divided by 2. It will be 19.215. So 2D is A upon H square plus K square plus L square sine 19.215 and 1 K L lambda is given 1.54. From here you will evaluate putting the value of A H K L. Here it will come 1 1 1. Similarly, using second, third, fourth, HKL values will become firstly for the second it will be 200 है ना. See, all for the first two only, when you will evaluate you will get all odd and even, so it will be FCC. Okay, and the answer will be FCC, this one too. This is not possible, right? Because it should be all HKL should be all even or all odd for FCC, right? Next question is, when silicon is dropped with group 5 element. Okay, silicon is basically group 4 element and it is dropped with group 5. So we know that this is a valence band, this is a conduction band, this is basically full, this is empty. A donor level will be created which will be near to the conduction band. So this is the second answer. So quantum confinement leads to, basically quantum confinement is decreasing the size of the atom, right? When we decrease the size of the atom, the gap between the valence band and the conduction band will increase. So the first option will be the right option. Then is, in the solid the filled molecular orbital contributes to, now only I have told you this two bands are there na, conduction band, below is valence band is filled while the conduction band is empty. So the filled correspond to the valence band and empty will be the conduction band. So thank you everyone. So this is a complete set of questions that came till June 2025 of solid state chemistry. I hope you enjoyed the session. If you have any doubt, kindly let me know in the comment section. In next video we'll discuss some other topics. Thank you.